Sorry guys, I had an interruption. My the battery on my microphone went low on charge. Therefore, I have to restart. Okay, we were describing pitch and frequency. Okay, the word pitch refers to the frequency. The sound with higher frequency are heard as notes with high pitch, and the sound with a lower frequency will be heard as a low pitched note. Okay, so a sound with high pitched note will have a higher frequency, and a sound with a low pitched note will have a low frequency. And small objects such as the string of a violin vibrates faster, therefore producing sound with a higher frequency and notes with high pitch. And large object, for example the string on a cello, vibrates slowly, therefore produces sound with lower frequency or low frequency and heard as notes with low pitch. Okay, frequency and pitch. Okay, investigating the frequency from CRO. CRO actually stands for cathode ray oscilloscope. You can simply address it as oscilloscope for your IGCSE, and the full name is actually CRO, cathode oscilloscope. And this is the CRO screen. Okay, you might have noticed it when you visit a patient in a hospital. The screen on the ECG machine that shows the heartbeat or heart rate of the patient. Okay, and using the CRO, you can investigate the frequency of a sound wave. How? First, connect the CRO with a microphone. The microphone detects the sound and converts it into electrical signal. Then the sound is shown, the wave is shown on the CRO screen as a transverse wave pattern. And from this pattern, you can investigate the frequency of the sound. For example, this is a CRO screen, and this is a trace of sound picked up by a microphone, then fed into CRO. Okay, this is the trace of the sound wave produced, for example. And suppose the CRO or the cathode oscilloscope is set at a time base of 0.01 second. When the time base is set at 0.01 second, this is the time base. Okay, the x-axis is the time base, and if the time base is set at 0.01 second, then one square represents 0.01 second. From the diagram, first you have to find out the period of the sound. Period, I think you know it, the period, the time it takes to produce one complete wave. Okay, the period of the sound wave first measured from the CRO screen. We can see this from this CRO. The sound wave actually takes 1, 2, 3, and 4 grid or 4 square. Okay, for completing one wave, the time it takes, the time period is equal to 4 into 0.01 second. So 0.04 seconds. This is the time period. You can also work it out by taking from crest to crest, 1, 2, 3, 4, the same. Okay, so the time period is 4 into 0.01 second, 0.04 second is the time period, and using the formula, you have learned it from the wave chapter, F is equal to 1 by T, you can find out the frequency of the sound wave. Okay, so 1 divided by 0.04, the answer will be the frequency of the sound wave. Now, audible range. Audible range, it is also known as hearing range. Every human being can hear sound that has a frequency of about 20 Hz to 20,000 Hz. This is the hearing range for average person, and also known as the audible range. Okay, we can also write it as 20 Hz to 20 kilohertz. Okay, so the audible range or hearing range for average person is 20 hertz to 20,000 hertz. You can hear sounds that have frequency from 20 hertz to 20,000 hertz or 20 kilohertz, but you cannot hear any sound that has a frequency that is below 20 hertz or above 20,000 hertz or 20 kilohertz. And the sound waves having frequency below 20 hertz are called infrasounds. Infrasounds. And the sound waves that have frequency above 20,000 hertz or 20 kilohertz are called ultrasounds. Okay, so infrasounds are sounds that have frequency below 20 hertz, and ultrasounds are sound waves that have frequency above 20,000 hertz. And this audible range actually varies from person to person. For average person, it is 20 hertz to 20,000 hertz, but the audible range gets narrower when people go older. Now, loudness. The loudness of sound depends on the amplitude. For example, if you hit a drum with a soft hand, the drum skin will vibrate with smaller amplitude, therefore the sound heard will be quieter. But when you hit it hard, the drum skin will vibrate with larger amplitude, therefore the sound heard will be louder. Okay, the loudness of a sound depends on the amplitude. The higher the amplitude, the louder the sound, and the lower the amplitude, the quieter the sound. Okay, now in your exam you are often asked to draw some trace of sound with smaller amplitude, or we can also say quiet sound, or suppose louder sound. For example, this is a trace on the CRO screen for a sound wave produced by any source, and that is picked up by a microphone and fed into the CRO. Okay, and if you are asked to draw on the same grid a sound with higher amplitude or a sound that is louder. Suppose this is a sound that is shown, sound wave, trace of a sound wave shown on the CRO screen, and you have been asked to draw a trace of a louder sound, just louder sound. Then increase the amplitude. Okay. The red one has smaller amplitude, therefore quieter sound, and the black one has larger amplitude, that's why it is louder. But look at the diagram, both the sound waves have the same frequency because the time periods are the same for both the sound waves. Another example, you are often asked to draw a sound with having varying frequency and varying amplitude, loudness. Suppose this is a wave trace, a trace of a sound wave produced on a CRO screen, and you are asked to draw a sound that is louder and higher in pitch, or the louder sound with high frequency. Okay, so louder sound, therefore the amplitude will be higher, and frequency, higher frequency, therefore the time period will be smaller, because f is equal to 1 by tf and t are inversely related. Therefore the red one is louder and higher in frequency. Okay, but if you are asked to draw a trace that it has lower frequency than the black one, okay, but quite louder, lower frequency but louder, then the diagram will be look like this. This is louder but has a frequency that is lower. Okay. Loudness. Sound waves in different materials. Sound can travel through any matter medium. For example, someone is talking on the other room and you can hear his voice even when the door is closed, because the sound is traveling through the wall. Sound can travel through the wall. This proves that sound can travel through solids. And other aquatic animals, for example, dolphins and whales, they can communicate. That means they communicate through sounds, and the sound is traveling through water. So this proves sound can travel through water. And you already know that sound can travel through air, otherwise we can't hear the sound produced by other person. Okay. And frequency, another thing, some animals communicate with lower frequency sound. For example, elephant produces infrasounds, and that's why not all the sounds produced by elephants can be heard by human beings. Some sounds we can hear from elephant, those have frequency that fits into our audible range. Okay, but most of the sound produced by elephants are infrasounds, and produces also sound, but we can't hear them because those are infrasounds. And some animals also communicate with ultrasounds, for example, dolphins. Another thing, the speed of sound. Okay, the speed of sound increases with increase in density of the medium. For example, the speed of sound in air is 340 meters per second about, and the speed of sound in water is about 1500 meters per second. The speed of sound in steel is about 5000 meters per second. Okay, so speed of sound increases with increase in density, sorry. And for doing the work example in your book, you will recreate this formula: F is equal to 1 by T, frequency N by N. The wave equation can also be used. If you know the frequency and wavelength, you can find out the speed of the sound, and you can find out anything if the other data is given. Okay, that's it for today, and I hope you find it useful. Okay, thanks for watching and see you soon. Allah Hafiz.